Alright, in today's lesson we are going to solve quadratic equations by using square roots. Before we get started in the actual lesson, there's a couple of things that you need to know about. Remember, a quadratic equation is any equation that has an x squared term, so something to the second power. If you have something to the second power, you are going to have either two solutions or you're going to have no solution. Now, we're not going to get in depth about no solution. That'll be more in Algebra 2. So just know that when we solve these equations, we're looking for two answers. Okay? So in this specific lesson, you're going to have examples that look like a squared equals b. And I'll show you how to get a by itself. So you're going to have specific examples. So you're going to have something like with an x squared equals c. Something with an ax squared, so a number in front of the x squared equals c, and then finally an ax squared, so a number in front of the x squared term with something after it, either adding or subtracting, and that's all equal to c. So those are the three example types we're going to see in this lesson. So again, x squared equals c, ax squared equals c, ax squared plus b equals c. Now, in order to get a by itself, in order to get rid of a square, we're going to use what is called the inverse operation. And to undo something to the second power or a square, the inverse is going to be a square root. So we can square root both sides here. That gets rid of the square, and that becomes a square. But remember, we talked about that we're going to have two possible solutions. So in order to get two solutions here, we're going to have one positive and one negative. So we say plus or minus the square root of b. So in today's lesson, all of our answers are going to have a plus or minus in front of the radical sign. You're still going to have to use what you learned previously on how to simplify radicals if needed. So let's take a look at some examples here. In example number 1, it says solve the following by using square roots. Example A says x squared equals 4. So if I want to isolate the variable, in order to get rid of this square, I'm going to square root both sides. So this square root cancels out this square, so I'm left with just x. And remember, we were talking about earlier, you need two solutions, so it's going to be plus or minus the square root of 4. The square root of 4 is 2. So my solution here is x equals plus or minus 2. If you're not sure of how I got 2, use your calculator. That would be second x squared. That brings up the radical. Type in 4. Hit enter, you get 2. Or use your factor tree. Two numbers that multiply to 4 are 2 and 2. Circle your pairs, cross one out, 2 goes on the outside of the radical. When we look at b, again, this is an x squared equals c, so it's equaling a constant. So when I square root both sides to get x by itself, remember I'm going to have a positive and a negative here. So this becomes plus or minus the square root of 12. Now 12 simplifies. If I use a factor tree, that would be 2 times 6. Factor tree 6, 2 times 3. Circle my pairs. Cross one out. 2 would then go on the outside of the radical. So this is plus or minus 2 on the outside. This 3 did not have a pair, so it goes back on the inside. So my final answer is plus or minus 2 root 3. In the next problem, notice this is of the type x squared plus b, so there's no a in front. I want to try to get x squared by itself, so I need to move this minus 8 to the other side. In order to do that mathematically, I need to add 8 to both sides. So this becomes x squared. That cancels out, equals 8. And now, like we did in the previous problems, I want to get the x by itself by taking the square root both sides. When I do that, the square cancels out, so x equals plus or minus the square root of 8. We can go ahead and factor tree 8. So that'd be 2 and 4, 2 and 2. Circle your pairs, cross one out. This 2 did not get circled, so it goes on the inside. This 2 goes on the outside. So my final answer is plus or minus 2, radical 2. In D, here I have an ax squared equals c. So the first thing I want to do is get x squared by itself. This 3 out front, the coefficient, means 3 times x squared. So in order to get rid of the 3, I want to divide this on both sides. So now that I divide that on both sides, the 3's cancel out, so I'm left with just x squared, and that is equal to 5/3. In order to get x by itself, so isolating the variable, I want to square root both sides. When I do that, the square cancels out, so I'm left with x equals plus or minus the square root of 5/3, which is equal to plus or minus the square root of 5 all over the square root of 3. Now remember, we cannot have a radical in the denominator, so I need to rationalize the denominator. That means I need to multiply the numerator and denominator by the square root of 3, so the number that's in the denominator. When I do that, I can multiply underneath the radical here, so this becomes the square root of 15. Square root of 3 times the square root of 3 is the square root of 9. Square root of 9 simplifies to 3, so my final answer here is going to be x equals plus or minus the square root of 15 all over 3. Okay, don't forget to rationalize there. Looking at problem E, same thing as D. Here I want to get rid of the 7, so I'm going to divide it on both sides. So I'm left with x squared equals 6/7. Square root both sides. So x is equal to plus or minus the square root of 6/7, which is the same thing as the square root of 6 all over the square root of 7. So I want to rationalize the denominator. So I'm going to multiply both numerator and denominator by the square root of 7. When I do that, I get x is equal to plus or minus, multiply underneath the radical, that's the square root of 42, all over the square root of 49. This simplifies to plus or minus the square root of 42, all over 7. If you factor tree 42, that breaks down to 2 and 21. 21 breaks down to 7 and 3. You don't end up with any pairs there, so the square root of 42 is as simplified as it can get. So my final answer is plus or minus square root of 42 all over 7. Looking at F, first thing I want to do here is divide both sides by 2 to get rid of the coefficient out front. When I do that, I get x squared equals 10. So now I want to square root both sides. When I do that, I get x equals plus or minus the square root of 10. If you factor tree 10, this is 2 times 5. There are no pairs to circle, so as simplified as it gets is plus or minus root 10. In example G here, this is the type ax squared plus b equals c. So again, mathematically inverse order of operations. I want to get rid of addition and subtraction first, then get rid of multiplication and division. So first thing I'm going to do here is subtract 2 from both sides. So I'm left with 4x squared equals 3. Now I'm going to divide both sides by 4 to get the x squared by itself. So x squared equals 3/4. And now I want to get rid of the square, so I'm going to square root both sides. So x equals plus or minus square root of 3/4, which then becomes x equals plus or minus the square root of 3 all over the square root of 4. The square root of 4 simplifies to 2, so my final answer here is plus or minus the square root of 3 all over 2. In example H, again here we have ax squared plus b equals c. So I want to get rid of this subtraction first by adding 4 to both sides. When I do that, I get 2 multiplied with x squared is equal to positive 4. Divide both sides by 2, which is the coefficient in front of x squared. So you're left with x squared is equal to 2. Now get rid of the square by taking the square root of both sides. So x is equal to plus or minus the square root of 2. Finally, in I, again ax squared plus b equals c. So the first thing I want to do is get rid of this positive 7 by subtracting 7 to both sides. So I'm left with 5 times the quantity x squared equals 27 minus 7 is 20. Now I want to divide both sides by 5, the coefficient out front, to get x squared by itself. So x squared is equal to 4. And now I want to square root both sides to get rid of the square. When I do that, I get x is equal to plus or minus the square root of 4. Square root of 4 is equal to 2. So my final answer is x equals plus or minus 2. Now I'd like you to go ahead and pause the video. Try the 3 U-tries on your own. When you finish the problem, go ahead and unpause the video and check your solutions. For U-try A, you should have gotten x equals plus or minus 3 root 2. For the U-try in B, you should have gotten x equals plus or minus 2 root 5. And in C, you're going to have to rationalize the denominator there, and when you do that, you get x equals plus or minus radical 33, or root 33, divided by 3. This concludes the lessons for solving quadratics by using square roots.